Okay, summation notation. This would correlate with lesson 2.1.2 and 2.2.2 in your book. All right, where 2.1.2 is where we first learn about sigma notation, what it means, and how to write a sum in sigma notation. And then 2.2.2 is the actual calculator program, which you have been given access to in class that you would need to write to be able to use to help you. Okay, so we're just going to review what this means. Two types of questions you're going to see here. First one, expand the following and then calculate the sum. So if I had to do a problem like this, when it says expand, that means I'm taking this equation, okay, and I'm going to substitute these numbers beginning with 1 and ending with 4 into this equation, and then I'm going to add all of those numbers together. So basically what I would do is I would start 3 times 1 squared plus 5, because it starts at 1, plus, and then I'm going to plug in 2. And then I'm going to plug in 3. And last I'm going to plug in 4. And then I would just determine and calculate that sum once I'm finished substituting all the numbers I need to. You can see that this ends up being a fairly tedious process without the help of the calculator. But once you have that program in there, the calculator will help a great deal. So I went ahead and expanded each of those. Here, let's see, 1 squared is 1, times 3 is 3, 2 squared is 4, times 3 is 12, 3 squared is 9, times 3 is 27, 4 squared is 16, times 3 is 48, and then I added 5 to each of those, added all of them together, I ended up with a sum of 110. Now we will expand sums that go greater than from 1 to 4, they might go from 1 to 100. That's why we need the calculator program to be able to help us with that. The second style of problem that you will see is when you're given a sum, like this one, and you need to write it in sigma notation. All right, the first step is always the easiest one, and that is to go ahead and write yourself that sigma there. The second step sometimes gets tricky, and no two of these are going to be alike. The more you do, the more familiar you get with them. But what I need to recognize here is the fact that my base is always 3. That's not changing, which means it's not going to change in the equation. So you're going to have a base of 3 there. Okay? Now what I need to also recognize is that my exponent is the only part of the problem that's changing. Now there's two ways to go about this. You can go about it starting with 1 or 0. I have no preference which you choose. I do believe that starting at 0 is the easiest way. Because if I turn this into a little table here, like I showed you in class, and again I'm only looking at the exponents here, and I start with 0, that makes my life easier because I already know what the y-intercept is. I know what the beginning value is here. Okay, so I can observe the growth, counts by 0.2. So my growth is 0.2. Give me a variable, we'll say k, plus my initial value is 3. So that'll be my exponent, 0.2k plus 3. Then I need to write my indices here. So k is going to start at which value? 0. And it's going to go to what value? 4. Something you need to know that I think I stressed quite a bit in class is that these two numbers, your indices, must always be positive integers. Remember that. They will never be decimals. I understand that these numbers here are decimals, and that's okay. Our equation takes care of that. If I plug in a 1 here, 0.2 times 1 is 0.2 plus 3 is 3.2. That's how I get the decimal there. But in my actual problem, these two numbers here, 0, 4, whatever they may be, in any problem you ever get up here was 1 and 4, they must always be positive whole numbers. And you'll see these problems in the homework over and over again. This is going to be essential when finding the area under the curve, which is the next lesson, and the next few lessons, because we're going to take a bunch of rectangles and try to add up all their areas quickly. And the more rectangles we use, the more accurate our area gets. So we want to be able to find a sum quickly. That's why it's important to be able to write something in sigma notation right now in this course.